Hello student. Today we will discuss elementary operations or transformation of a matrix. Actually, elementary transformation or operations are certain operations which are applied in matrix, and mainly we will apply this operation in matrix in our case just to get the inverse of the matrix. So first we will discuss what are your elementary transformation, and later on we will apply them. How to apply, later on we will discuss how to apply them to get to find out the inverse of a matrix. So let us see what are your elementary transformation. There are 6 elementary transformation on a matrix. 3 of them are, 3 of which can be carried out on rows, and 3 on columns, which are known as elementary transformation or elementary transformations or operations. That means now we will discuss 6 elementary transformations. Out of all these 6 transformations, we will apply 3 in rows, and they are known as row elementary transformation, and 3 of them are applied in columns, and they are known as column elementary transformation. Now let us see what are the transformation. So first here I am writing, these are the interchange of any 2 rows or columns. Here actually we have discussed 2. One is the interchange of any 2 rows, that is in row transformation, and the interchange of any 2 columns, that is in column transformation. So it means if I consider, suppose the ith row of a matrix and the jth row of a matrix, that means we consider any 2 row of the matrix, and then it is possible to interchange them. That means Ri takes the position of Rj and Rj takes the position of Ri. This is symbolically denoted by this one. That means row, ith row and jth row can be interchanged. Similarly, we can apply the same transformation in column also. That is what? Interchange with jth column. Ith column is interchange with jth column. It will be denoted by Ci takes the position of Cj and Cj, both side arrow Ci. And you see, when we apply this transformation, we will get a new matrix, and that is not same with the original matrix. That means we will get an equivalent matrix. Let us see how to apply. Just an example. Okay, I am taking here A. A is any matrix. Suppose it is first row is 1, 2, 3. Second row of the matrix is 4, 5, 6. And the third row is 7, 8, 9. Let us apply the transformation R1 interchange with R2. That is R1 takes the position of R2, R2 takes the position of R1. Then in this case you see R3, row 3. R1 means first row. First row takes the position of second row, and second row takes the position of first row. In this case the third row remains as it is. So I am first writing third row. Then you see this is the second row, this is your first row. This one you write down here, and this one you write down here. That means your first row become now 4, 5, 6, you see here. And the second row, second will be replaced by the first. So it become 1, 2, 3. And the third row remain as it is. Here this is a symbol of equivalent matrix. So we get an equivalent matrix. This is not similar with A, not same with A. Not equal with A. It's an equivalent matrix with A. Okay. This is the application of the first transformation. You see, I'm just want to tell you how to use them in column. Suppose we are going to apply this transformation in column 2 and column 3. That means interchange column 2 and 3. So if you want to apply in column, then in this case you write down the answer in terms of column. So your first column will be equal to what? 4, 1, 7. An equivalent matrix will get there. The first column will be 4, 1, 7. Second column takes the position of third column, and third takes the position of second. So in the equivalent matrix, your new matrix, the second column will become 6, 3, 9, and a third column will become 5, 2, 8. This is the way of using this first transformation. Now you see, let us go to the second transformation. Your second transformation is the multiplication of elements of any row or column by a non-zero number. That means it is possible to multiply any row or any column by a non-zero number. Then you will get a new matrix, okay, which is equivalent to the previous matrix. And it is symbolically written as this way. Ri, suppose the ith row I want to change, you can multiply by k into ri. তুমি যিটো ৰো লোৱা হেতুক তুমি এটা নন জিৰো কনস্ট্যান্ট দি মাল্টিপ্লাই কৰিব পাৰিবা আৰু মাল্টিপ্লাই কৰা মানে ডিভাইডেড অলসো পসিবল because if you multiply by the multiplicative inverse, suppose you are dividing by 2 or multiplication by half, is not it same? So multiplication possible means division is also possible because we are using here non-zero number. So if you apply it in column, it is denoted by ci takes the position what or change by k into ci. Okay, now let us see how to apply it. We are taking an example. This is suppose a. আমি এটা example লৈ লৈছো ধৰা a2. I want to use here suppose c2 change by half into c2, or you may write down c2 by 2. In this case, I am applying this operation in column 2. So first and the third column remains as it is. You see here, this is the first column. I am writing as it is. This is the third column, minus 136 minus 136. Now I am applying this in the second column. So c2 by 2. 2 by 2 will gives you 1. Here it is 1. 1 by 2 is half. 4 by 2 is equal to 2. So this is a new equivalent matrix we have got. That means it is possible to what? Multiply any row or column by a non-zero constant. Then we will get a new equivalent matrix. And this is your second transformation. You remember your transformation. Later on we will discuss how to apply them. Okay, to get the inverse. The third transformation is what? You see, the addition of the elements of any row or column, the corresponding elements of any other row or column multiplied by any non-zero number. You see, what does it mean? That means we are taking any particular row or column, then we multiply any other row or column by a non-zero constant, and then that new numbers are added with the corresponding elements of the previous row or column. Suppose how to apply, let me tell you in symbolically, it will be more simple for you. Suppose we want to change ri. How to change ri? You keep it is ri as it is, multiply other than ri any row by a constant. Suppose I am selecting row rj, zth row. You multiply zth row with what? K, non-zero number, and then add with the corresponding elements. Similarly, we can apply in column also. Ci takes the position what? Ci plus kcj. If I write down here Ci, here also it is Ci. That means if I select column 1, here also it will be column 1. Then multiply column 2 or column 3 by a non-zero number, that is by k, and then you add the corresponding element with c1. Add means subtraction is also possible. Because if you, same thing as in the case of multiplication. Multiplication means division possible, and what? Addition means if you add by the additive inverse, that is subtraction, is not it? So addition means subtraction is also possible. Let me give you an example, it will be more clear to you. Suppose I am taking a matrix, say 2, 1, 3, minus 1, 0, 0, 0, 3. Suppose I want to change row 2, then you have to write down here row 2. Row 2, suppose I want to multiply row 1 by 2, and then it is added. So you see, I am writing the results here as a rough work. Your row 2, what is your row 2? I am writing first minus 1, 0, minus 1, 0. Then what I want to do? 2 into r1. That means r1 we multiply by 2. This is your r1. 2, 1, 3 multiplied by 2. It becomes 4, 2, 6. So this is 4 to 6. Then what I have done? r2 plus 2r1. That means we are adding these elements now corresponding. So minus 1 plus 3 gives you 3. Minus 1 plus 2 will give you 1. 0 plus 6 will give you 6. And these are the number by which we have to replace the second row. So second row elements are now first element 3, 1, 6. Keep the third row as it is. Okay, this is the way of application. So these are the transformation we have to know. I'm giving you in case of some results in terms of rows and some are in terms of columns. So these are your 6 transformation. Actually similar. 3 of them are applied in row and 3 of them are applied in column. One more thing in the case of elementary transformation you have to remember, that's a very important thing, that is what? If you start a problem with row element transformation, then complete the problem with row transformation. Don't mix up both row and the column. Or suppose you are starting a problem with solution of a question by using column transformation, then complete it by column transformation. Don't mix up them. Row and column you cannot combine together. In one problem you cannot apply both of them. Okay, hope you understand that thing. Now, okay, just a minute. Now you see elementary transformation. An elementary transformation is called a row transformation or column transformation according as it is applied in row and column, as I told you earlier these things. Now, here I had already told you that this transformation we are going to apply to find out the inverse of a matrix. Okay, so now first see what is our inverse of a matrix. Okay, that is when a matrix is said to be invertible. Invertible matrices. So you see, if A is a square matrix of order M, and if there exists another square matrix B of the same order M such that AB is equal to BA is equal to I, then B is called the inverse of A, and it is denoted by A to the power minus 1. So when we call a matrix as invertible, first thing we have to know it. If you want to find out the inverse, then you must have a square matrix. So I am taking an invertible matrix, suppose a matrix A. Tumalke eta matrix A dhori lua. And then after getting A is a matrix, you just try to find out another matrix B. And you see the order of B must be similar with what? A. Same order. So you try to get a matrix B, and that matrix B, when you multiply with A, you must get the identity element. And also AB is equal to BA. That means it is commutative. Then we call B is the inverse of A. Hope you understand it. Tumalke ki koriba? Eta matrix A dia thakibo, matrix tumalkor square matrix hobo lagibo. Ar tumaluke jodi eta square matrix B uliabo para same order or jate ki hoy, when we do the product of A with B, it is commutative, and the result, the product AB, must be an identity matrix. This is a very important case. Then we call B is the inverse of A, okay, and it is symbolically denoted by A to the power minus 1. And in the case A is said to be invertible. Okay, so here you see I am writing what? B as A inverse. B is the inverse of A. And one more thing you have to know, that is what? If B is the inverse of A, then A is the inverse of B also. So the A to B inverse hoy, then B to A inverse hobo. Ba ulta ke kobo para, B jodi A inverse hoy, A to B inverse hobo. And then you see I'm giving an example. So suppose we are taking A as 2, 3, 1, 1, 2, and B is another matrix 2 minus 3 minus 1, 2. Two matrices. Let us do this product. Suppose we are getting B somehow. Okay, then we do the product. First we substitute A and then B, then do the product. First row, first column, 2 to 4, 3 into minus 1 is minus 1, 4 minus 1, first element. First row, second column, first row, second column element. That is what? 2 into minus 3, 6 plus 6, 6 plus 6. Second row, first column, this is the position. 2 into 1 is 2, 2 into minus 1 is minus 2, 2 minus 2. 1 into minus 3 is minus 3, 2 into 2 is 4. So, minus 3 plus 4. Then calculating, we have got it I. Now you see, we have find out B in such a way that the product of A and B will gives you I. But you see, the process of finding out this B is not very simple. Tumalke yate moi likhi disu karone gom paisa, kintu tumalke kene ka B to uliaba. A B to uliwar process to karone ame ki korim? Element transformation use korim. And also we have checked here what is the value of BA, and doing the calculation we have seen it, this is I. So here we have done that AB is equal to BA is equal to I, therefore B is the inverse of A, and it is denoted by A to the power minus 1. Okay, then one more thing, that is some note I had given here. As for short question and multiple choice question, we have to know these things. A rectangular matrix does not possesses inverse matrix. আমি ইনভার্স উলিয়াবলে হলে ম্যাট্রিক্সটো কি হ'ব লাগিব? স্কয়াৰ ম্যাট্ৰিক্স হ'বই লাগিব। Inverse of a matrix, if exists, is unique. That means whatever the method you apply, your answer will be always unique. সদায় একেধৰণে একেটা answer পাবা প্ৰত্যেকই. And if you do the product of the inverse, then it will be reverse. A whole inverse takes the position B inverse A inverse. If A and B are invertible matrices. These things you have to know. Okay. Now you see, so here as I told you that in the invertible matrix we understood, what are the transformation we understand. Okay. Now we have to know how to apply this transformation to get the inverse of a matrix. I am giving you certain steps here. So if you remember the steps or follow the steps, then you will easily get the inverse of the matrix. Otherwise, the problem is very complicated. তোমালোকে এপ্লিকেশনটো যদি ভালদৰে ষ্টেপছবোৰ নাজানা, আমাৰ কি হয় এলিমেণ্টাৰী ট্ৰান্সফৰ্মেশ্যনত যেনেকৈ আমি এপ্লাই কৰিম, তোমালোকে কুৱেশ্যন মই পিছত ডিছকাছ কৰিলে গম পাবা, আমাৰ কি হয় আমি এটা চেঞ্জ কৰি লওঁ, আকৌ বেলেগ এটা ট্ৰান্সফৰ্মেশ্যন ইউজ কৰোঁ, লগে লগে আকৌ সেইটো নাইকিয়া হৈ যায়, এনেকৈ ঘূৰি থাকে, গতিকে আমাৰ প্ৰব্লেম হৈ যায়. ডেটছ ৱাই উই হেভ টু ফ'ল' চাৰ্টেন ষ্টেপছ. So see, method of finding out the inverse of a non-singular matrix by elementary row transformation. I am giving here the steps for getting row transformation. Okay, the similar steps we can do for column transformation also. Let A be a non-zero matrix of order n. Example we will discuss later. Okay, so A be a non-zero matrix of order n. First always you have to write down this step. What A is equal to in into A or A is equal to A into in. This is applied in row transformation and this is for column transformation. Okay, here in means whatever the order of A order G2 hoy, that I matrix to order to K hobo. 2 by 2 hole 2 by 2 hobo, 3 order 3 hole order 3 hobo, and so on. Perform a sequence of elementary row transformation successively on A and I on the LHS of on I on the right hand side till we obtain the result as I is equal to BA. That means here you see I am taking about this one. You have to apply transformation in A on the left hand side, not both A. The A on the left hand side and I on the right hand side. And you have to apply the results until up to that step till this A convert to I, identity matrix. And this immediately, this I, same transformation we are going to apply here also. This will convert to a new matrix B. Okay, then the result will become I is equal to BA. Okay, and I is equal to BA means what? I is equal to BA means the product of two matrix equal to the identity matrix, then B is the inverse of A. Now, what are the transformation? Here I am giving some star marks. What are the transformation we have to apply? The following steps will help you to find out the inverse of a square matrix of order 3 by using elementary row transformation. So first you see, as you know the what is third order, for third order I'll give you the steps. So suppose I am taking a third order matrix, then you know the position. Okay, so for first we have to introduce 1 at A11 position. A11 position means the first row, first column position element. That is the first diagonal element. You make it 1. And for this purpose, what transformation we have to use? Position either by interchanging the two rows or by adding the constant multiple of elements of some other row. That means either you have to use second transformation or we have to use here the third transformation. You may use the second transformation also, but we'll try to avoid that, because if second transformation is used, then sometime it become fraction. So second transformation always, if you apply second transformation, always the result leads to 1. Second transformation to use korle 1 pabai. Kyoswa, whatever the number you have, if you divide it by the same number, always you will get it 1. Is not it? So second transformation use korle tumalke hodai 1 pabai. But we try to avoid that because it sometimes leads to fraction, and doing the calculation with fraction is sometimes more tedious and time consuming. That's why we try to avoid, and we are applying the first, that is interchange the any two rows or the multiply the any other row or column by a constant, and then it is added to that particular row or column. That is the first step. Prathamate A11 to 1 kori loba. After this, the second step. After introducing the first 1 at the 1 position, A11 place, introduce 0 at all other places of first column with the help of first row. First you read the transformation, try to clear them, we will do it, apply it later. And you see, the first we have got at A11 position is what? Equal to 1. After it, you see, you will have a column. Below them, you will have certain element. For 3 by 3 matrix, you will have two more element. And then you try to make them 0. What are the position you see? Your position are 2, 1 position and 8, 3, 1 position. That 2 position, you try to make it 0 with the help of the first row. Or 0 keneke koribo pariba, moi tumalok problem korte discuss kori goi thakim. Okay, so introduce the third step. Introduce 1 at A22 place with the help of second or the third row. Ebar tumalke A22 position to 1 banwa. You try to make, this is the second diagonal element. You try to make it 1. And then when you want to make it 1, don't take the help of row 1. Because row 1, we have already make 1, 1 position, A1, 1 position 1. If you take the help of that, it may change that value. Okay, so you take the help of the second or third row and make it 1. For that purpose, you can apply any transformation. Divide it or any transformation, it means sometimes you can divide it to get 1 or the first transformation, second or the third. But you see, we applied for row because we are proceeding row transformation. After getting 1 at this place, you take the second column and make the other elements of the second column equal to 0. Introduce 0 at all other places in the second column with the help of row 2. Tumalke to A22 position to 1 banaisila. So that after that, you take the help of row 2. Don't take the help of any other rows. And the same way, next step, number 5th step, you make A330. Okay, third diagonal element. And that is done by using third row only. Third row help hote tumi third row element to ki koriba 1 banaba. That means you just divide it. Second transformation apply. And after getting that, you introduce 0, finally 0 at all other places of the third column. Okay, with the help of the third column. Etu kintu kar help koriba? With the help of the third column. Etu koriba. Korar loge loge tumalke ki paba? You will have on the left hand side will be a matrix I. LHS. Immediately on the right hand side, first matrix also we are applying them, and that will convert to a new matrix B. Okay, third one remains as it is, so it will be in your required form. So here you see, sometime as a note, it's a very important thing. After applying one or more element transformation, sometime what happen? A and IA or A into IA. If we get all zeros in one or more rows or matrix A on the LHS, A inverse does not exist. Keteba ami application to kori thaku te amar ki hoy ei keteba amar problem to ki hoy je hebur element bur amar 0 hoi jay, so protekta element te amar 0 hoi jay ar tetiat ami kintu he transformation to aru apply nokoru. Hobo ekhini kotha tumake monat rakhiba tene hole tar pisot tumalke swa ei je ami application khini korilu ei application khini korar pisot kintu amak ki lagibo আমাক বেলেগ বেলেগ ৰিজাল্ট আমি এপ্লাই কৰিব লাগিব হেখিনি কথা তোমালকে খুব ভালদৰে মন কৰিবা আৰু মই নেক্সট ক্লাছত তেনেহলে তোমালকক কেনেকৈ এপ্লাই কৰিব লাগে এক্সাম্পলত কৰি দেখাম তো ফাৰ্স্ট তেতিয়ালৈকে তোমালকে এইখিনি কথা ভালদৰে মন দি পঢ়ি লবা থ্যাংক ইউ